on Git, but now we're actually going to access the Pangeo deployment. So we're going to start doing some work on the cloud. But before I get going with all of that, I just want to introduce myself and let you know about me and Joe and Don, who are going to be running this session, and then you'll see us again on Friday. So I'm Lindsey Heagy. I'm a postdoc at UC Berkeley. I'm working with the Jupyter team. My background is in geophysics, and so broadly I work on Jupyter in the geosciences.
Sure. All right, hi, I'm Don Setiawan, and I am a software engineer at the School of Oceanography. My background is in oceanography, and I deal with just Python packaging, Conda, and later on I will talk about what that is, and yeah.
I guess you heard me this morning too, but I'm Joe. I'm here, an incoming student at UW. I'm going to start in the fall, and I have a software background, so that's why I'm also part of this Geohackweek teaching.
All right, so now that you know who we are, feel free to flag us down at any point if you have questions. We'll try and make use of the sticky notes, but also feel free to just wave, and one of us will run around and help answer questions. So what we're going to do now is go to the Pangeo for this week. So this is a cloud deployment of Jupyter. And so what you're actually going to be doing is accessing compute resources that are on the cloud. And so if you go to this URL here, nasa.pangeo.io, I can give everyone a moment to get there. See a few screens that look like they're getting closer. nasa.pangeo.io. Okay, so all right, I see a number of screens with the Pangeo logo on there, so I think we're in good shape. If you can't find the site, just raise your hands, and Joe and Don can come over. So what you can do is you can sign in here with GitHub, and if you're already authenticated, like so, my browser right now is already signed into GitHub, so it should be smart enough to recognize my credentials. We'll give it a moment. It looks like it is spinning and thinking. Oh no. Is anybody else or others able to get on? You might end up reaching a page. Oh, sorry. So right now I get to this. If you have not actually logged into the hub before, you might land on a page that asks for permission to access your account on GitHub. So please do accept that. And then when you get to this page here, there's a few different options. Click on the second one here, which is Geohackweek 2019. And then you can open that up. And so what this is doing is actually, so there's a Jupyter Hub deployment. And so now when you log in, it's setting up your Jupyter environment. And so in a moment here, we're going to land on a Jupyter Lab page, which is basically your portal to the cloud. So in there, we can access a terminal. We can access notebooks, we can make markdown files or other types of plain text files, all those sorts of things. So it basically is your interface to a computer in the cloud. So it's taking a moment, but should get up and running here shortly. Well, while it thinks, what we're going to be doing now is we're going to actually clone the data sharing repo. So the repo that you all just forked, go and copy paste the URL for that. So here I have my GitHub username is lheagy, and then I've fork of the data sharing repository. So I'm just going to copy this so that once our hub is up and running, I can go ahead and clone this repository. And if you're curious what's going on, you can actually open up the event log, and it tells you a few things, what's all going on. It's nice to just see that something in fact is happening when it's spinning up here. Is it going? It's so much faster this morning. Maybe because everyone's logging in.
Sorry.
Yes. Yeah. Just try again. It might be because so many of us are trying to log on at once. You can refresh the page, or like just go back and start again.
Just out of curiosity, does everyone know what the Pangeo project is? I feel like some of you know really well, and some of you don't know at all. A lot of people here don't know. Go ahead. 2 minutes on Pangeo.
Yeah, sure. So Pangeo is an effort that brings together Jupyter. So are folks here familiar with Jupyter, actually? First question. Jupyter Notebooks, okay. Yeah, so many people are aware of Jupyter Notebooks, and that's sort of one of the core pieces of technology and what Jupyter's most well known for. So Jupyter is all about interactive computing. And so the notebook is the user interface that you see. Now Jupyter Lab is the newer updated version of that. And so what Pangeo does is Pangeo actually combines Jupyter with open source tools that are useful for high performance computing in the geosciences and scalable computing in the geosciences. So there's packages like Xarray and Dask. So Xarray is for data management and Dask is for parallel computing. And so these two projects, although they're generally useful, have really been led by the geoscience group. And so by combining these tools and deploying them on the cloud, Pangeo has basically opened up a lot of options for geoscientists to actually start doing cloud computing. All right, are most folks at a page that looks like this? Yeah, we'll get there. I just want to make sure people are getting here, but like in terms of. So all that I did was, once you get to a page that looks like this, just open up a new browser tab and grab your data sharing, URL. Anthony, can you just double check that I didn't screw up my screen sharing? I think I might have. So copy the URL here for clone. I dropped it. Okay, so you copy the URL for your fork of the data sharing repository. So here I just clicked on this copy button, and then you can go back over to your Jupyter Lab. And what we'll do here is see there's a few different things that you can open up. We can open up notebooks, and so we'll get there in a moment. But here, let's start by opening up a terminal. And so all we're going to do here is then do git clone and then paste that URL.
Lindsey, is it right that pasting requires pushing the shift key as well, as I recall?
It shouldn't, or at least it doesn't on a Mac.
On my Linux machine, I have to hold the shift key as well as right click.
Because I just did, so when I did copy paste, I had copied the URL and then I just do Command V on a Mac. All right, and once you have done that, you should see in your file browser on the left-hand side here, a folder called data sharing. So that's the repository that we just cloned. So it's the same thing as what you'd done before, but now we're actually just doing this, we're doing this on the cloud. So instead of cloning to your local machine, we are now cloned to your cloud environment. And so if you go inside of there, there's a few different files that we've got. You can see that these are the same as what we have in the repository, things like a Readme, a license, and all of that. But importantly, we're going to go into the notebooks. So if we go back to the Jupyter Lab, we go into notebooks. There's a few different notebooks here. So the first one is an introduction to Jupyter. So if you just double click on that, a Jupyter Notebook document will open up. So give people a moment to get that up and running. Yes. Yeah, try and copy the HTTPS rather than the SSH for GitHub. Okay, so how many of you have actually used Jupyter Notebooks before? Can I get a show of hands? Okay, so maybe 65%. So this tutorial is, this first one we'll go through fairly briefly, but if you have more questions, I'm happy to chat in a lot more detail afterwards as well. But what this is meant to do is just give you a bit of an overview of what the Jupyter Notebook is. And this is based on Fernando's notebooks. He gave a tutorial a few weeks ago at the ISAT2 Hack Week. And there's a link right here, Intro Jupyter Git. If you're looking for more information or another perspective on Git, there's a collection of notebooks that you can check out. But if we start here, what you can think of when we think about a Jupyter Notebook is it's really an interactive computing environment. That means we can combine live code, we can combine widgets, and we'll show some examples of that. Plots, you can combine text, so that's what we're looking at here. This is just plain text that has links. We can have images and videos. And so when we actually are looking at this document, there's three pieces of things that are actually coming together to have this be not only just a document that you can look at and that's rendered nicely, but something that actually can execute code. And so the notebook web application is what you see. But what's going on behind the scenes is we have something called a kernel. And so what that is it's a process that's been started by the notebook that basically it knows how to interoperate with Python or with any other language. So there's about 130 different kernels that you can install, meaning there's 130 or so different languages that you can interact with through Jupyter. But we're going to be focusing mostly on Python. So we use the Python kernel. And so what it knows how to do is when you send commands from the notebook, they go to the kernel, and the kernel knows how to compute with those and send you back results. And then this entire document that we're looking at, what's actually saved is a .ipynb, and that is a notebook document. So that's actually just a JSON file. If you wanted to open it up in a plain text editor and see what the data structure is like, you can. Lots of curly brackets and quotes and such. So it's an ugly document to look at when you look at it in plain text. But we know how to render that into something that is human readable and nice to work with. So when we're looking at the web application, there's a few different things that you can do from here. We can edit the code. So here, if I wanted to go and edit the text, I just double clicked and I can go in and say, hello, Geohackweek, and rerun that. And now that shows up right here. So you can go in, it's a live editable document. And you can run code, and we'll show some examples here of rich representations. So as I mentioned, over the 130 or so programming languages, there's a link here if you want to actually go check out if your favorite programming language is there. So there's a few different types of cells when we look at a document. So right now you can see here this is Markdown, and you can tell that by looking up here. This is the cell type. We could change that to be raw, and so then what that does is it actually just shows you the plain text version of that. So sometimes that's helpful if you want to actually show people some template code or something like that. And then there's also code cells. And so a code cell looks something like this. You can go ahead and we actually have a Python statement, and I run that by doing Shift Enter. And so that then pops out the result. And then this is the same raw cell that I just showed you before. And you can go up and change these just by playing with the different cell types. So if I wanted that to be Markdown instead, you could do that. There's a couple things that are visual cues that are there to try and help you understand where you are in the notebook and what's going on. And so you can see here, this blue bar, it shows you that I'm in that cell right now. And that means we can go in and edit it. And so blue denotes that you are editing the cell. So here, if I come in here, it shows it's blue. And then the number on the side updates, and that tells you how many cells you have run, how many different code cells you have run. So I've been using Shift-Enter. That tends to be the most convenient once you get comfortable programming. But you can also go up here and you can use the play button. So that also runs a cell. That's the same thing as if you go up into the run menu and you can run cells above or run cells below. You can run all cells. So sometimes I found it handy if you're giving a notebook to a collaborator who doesn't necessarily know Jupyter, and maybe you've put a nice widget or something in the bottom and you want them to be able to get up and running with it. Just tell them, okay, go to run all the cells, and then look at the last output. That's what we want to be having our conversation about. So that's a fairly easy way to get other people up and running. There's a few different cell shortcuts that are helpful, and you can always pull these up. I believe it's help, and then oops. Jupyter reference brings you to the documentation, for example. But here's a small subset of handy navigation tools. But Shift-Enter is the one that you'll be using probably the most. And then I end up using Escape A, and Escape B quite a bit. So Escape A adds a cell above, and Escape B adds a cell below. So here we can run some cells. And there's a couple of things. So when you're running a cell in the notebook, if you don't have a print statement and you're not assigning a variable, it's going to assume that you want that output printed, right? So when we assigned A equals 10, no output was shown. But here, when we print something or we don't assign, it prints out the output for you. There's a couple things that are helpful to know about what's going on when code is processing. So code is run when so it's run, like the kernel is actually what does the processing of the code. And so what I'll do here is I'm going to run this cell. And if you actually watch, so here there was a number 11 because that's where it was saved. But when this is running, there's going to be a star in there that shows you that it's running. And when it's done, a new number will output. So this is meant to just give you a helpful visual cue of like something's going on, it's thinking. You can also see up here that this circle is filled in. It was filled in, and then when it finished, it opened. So there's a couple of visual cues to let you know, like, hey, I'm thinking versus the output is done. Sometimes you'll run some code that is too big, for example, on the Pangeo, or you'll run something that has an error and it'll cause the kernel to die. And so what this is, you don't need to worry about what this code actually means. In fact, I don't know what a CDLL is. So all that this is it's a sample code that is actually going to cause our kernel to die. And because I want to show you what that looks like. So sometimes you get a message like this. What that means is that the kernel has died. So that kernel, the backend process that was running the code, has died. And so any imports, any work you've done, any variables that you had above have now been lost. And so you now need to restart the kernel, but you can restart it and then keep moving along. So before, when we had set a variable A, at this point in time, A is not in our namespace because we had to restart the kernel, and that gets rid of everything. And you can see that it started again from number 1. So I showed you briefly the cell menu. The other thing that's helpful to know is sometimes you actually did run a cell that was too big by accident. I tried to multiply ginormous matrices and didn't intend to do that. And now it's sitting there spinning. What do? You can go to kernel. You can interrupt the kernel. So that stops the current computation, but keeps your entire namespace. So if I had here, if I assign A equals 10, and then I go and interrupt my kernel, A is still a variable that exists. Whereas if I go and I restart my kernel, warns you, all variables will be lost. A no longer exists. When error messages and things like that happen, this is just meant to show you that it is actually printed, it's sent back to you, and it usually shows up in a red bar. So if you're running some code and you run into an error, the red is a visual cue that there's some sort of error and there's a useful error message in there. When you're actually running output, one of the interesting things about the IPython kernel and with the notebook is going to immediately show you outputs. It's not going to wait until the entire computation was done. So when I ran this, you see 0 pop up, then 1, then 2. So it's firing back the outputs and showing them to you visually while the computation is in process. It doesn't wait until the entire thing is done and spit it back. So that can be helpful if you're running sort of a bigger piece of code and you want to just include print statements of like, hey, it's taken this long to do this piece of a computation, things like that. You'll get that information back in real time as the computation executes. One thing that's handy too is if we did a big number, so here we're printing out 50, that's a lot of text. So there's a helpful visual cue where we can go in and expand the cell and contract the cell. So, oops. So it just scrolls down so that it doesn't take up as much visual space. The other thing is, so when you're writing text in Jupyter Notebooks, it follows Markdown, so you can use Markdown. So if you want to go in and italicize text or bold text, things like that, you can double click here and you can see how all of that formatting is done. Things like lists and numbering. So that's all formatted nicely for you. Headings, as well as embedding code. So if you want to embed a little code snippet to talk people through what you're doing, it's all rendered for you like code. And then similarly with equations. So in a lot of cases, you want to state like, hey, I'm actually solving this integral equation. This is how I'm doing it. And so all of that follows LaTeX. So you can use the double % or double dollar signs for a new line or a single dollar sign in the same line. Once you start getting familiar with GitHub, and you might end up using some of their markdowns, they've extended Markdown a bit to include some nice things like syntax highlighting. So here, if we use 3 open quotes and then you say Python, then the GitHub flavored Markdown knows that, hey, this is Python code. Let's highlight it like Python code. Similarly with JavaScript. So that can just be visually very helpful if you're showing sort of bigger blocks of code. You can embed things like images. So you can do that. It's with HTML commands, basically. Images and even animations and things like that. So there was a little MP4 file in the images folder, and we just included it by doing exactly this. One thing to note, so the notebook server acts like a generic file server for anything that's inside that folder. So you have access to, you basically have access to running a terminal in whatever folder you're working in currently. So if you go in and delete stuff, it will delete those files. So that's just something to be aware of as you're working with the notebook. Does anyone have questions here on, this is sort of like the bare bones basics of working with Jupyter? Now, was everyone successful in getting, we have thumbs up that people have this repository and are on the hub? Okay, excellent. So now I want to take you through the next notebook. So this one is called Beyond Plain Python. So if you double click on this one, so beyond just executing code, the IPython kernel has a number of features attached with it that are really meant for interactive workflows. And so by this, I'm going to show you a few examples. So here I already showed you the shift enter. So one thing I'm just going to do, I'm going to restart and clear all the outputs just so that you actually see things changing as I run, because it's not much fun to see the answers. Okay, So here we can go ahead and print. So we've seen that before. One of the things that's extremely handy is the question mark. And so the question mark actually brings up documentation. So here, when I run the question mark, it assumes right now you just want some information on IPython. So here's the documentation on getting help within IPython. So the question mark is going to give you the overview. We can look actually at specific objects. So for example, here, a library that you'll end up working with quite a bit is NumPy. So NumPy does matrices n-dimensional matrices in Python. So it has a lot of the same tools that you would be used to using if you are used to MATLAB. So building up arrays and vectors and multiplying them and such. And so if I look and I saw that there's a function called np.linspace, and I don't really know what I should be providing as inputs, what you can do in the IPython kernel is you can put a question mark after that, and then we run Shift-Enter, and it's actually going to pull up the documentation for that. So here, np.linspace, I know that I now need to provide it a stop, or sorry, a start, a stop, and then you can provide it a number of points. And what it's going to do with that is giving you evenly spaced numbers over a specified interval. So just with the question mark, now I've gotten a lot of information about this piece of code that I'm going to be running. If you use two question marks, what that does is that actually pulls up the code. So here, if I run that on np.isClose, because I want to know what that does, but beyond knowing just its documentation, I actually want to see the code. So here, that actually pulls up the code. So we can see it's a function that takes a and b and has some tolerance. We can see the documentation for it. And then we can actually see this is the code that executes isClose in NumPy. You can use things like the star. So if people are familiar with doing search in Google or with regular expressions, you know, the star means like anything before and then anything after int. So if I look at, if I bracket int with stars, we look for basically what are the things in my namespace that have int in it. So these are the things that currently exist in my namespace. So an integer, we also have the print statement that has that breakpoint, etc. So if you sort of have something on the tip of your tongue and you know, like, okay, I know that these three letters are actually in the title, but you don't remember the name offhand, this can be helpful for finding things that are in your namespace. And then here, there's just a handy tool. This is a Magix within IPython that pulls up a quick reference for you. So here's some useful commands if you want sort of those day-to-day ones that we end up using quite a bit. And we'll go through a few more of these. There's lots of them. Okay. Has anyone seen the tab completion before? Yeah? Okay, so in this case, I've typed np dot, and if I hit tab, what it's going to do is it's going to look for all of the attributes that are attached to np. And in this case, I've imported numpy as np. It should show up. Maybe. Yeah, so it seems to be a bit slower. Usually what will pop up is you'll see a list of possible names that follow whatever values you placed here. Or if you go just after the period, it'll bring up all attributes. And so NumPy is a pretty big package. And so it was probably trying to pull in too much information at once. Yeah, I've noticed that sometimes the tab completion is a bit slower in Jupyter Lab. I'm not entirely sure.
It felt like we're all the same, right? We're all spun up separate.
Yeah. Yeah. No, but I have noticed that the tab completion sometimes is slower, especially if it is a big thing. So the NumPy is probably a poor example for this. You've got it. Okay, excellent. What did you use so I can demo it? Okay, sure. Maybe not. Oh, there we go. Okay. Okay, so the tab completion does in fact work. And so it's now going to show everything that is attached to the X-ray namespace. And so there are some handy visual cues, like here, it tells you that align is a function. So that can be a really helpful tool. I use that a lot when just trying to explore and get familiar with a new package, is just using tab completion to understand what's there. Another thing that's quite handy, so here if I run a computation, very simple computation, 2 plus 10, I get the output as 12. But sometimes you then find yourself being like, oh, I need to actually access that variable because I want to do another computation on it. And so one of the things that's handy is the underscore is reserved in IPython, and that actually saves the value of the last output. So in this case, when I do underscore plus 10, that's 12. So if you ran a big computation in the cell before and you forgot to assign it to a variable, you're not lost. You can use the underscore and recover and grab that value. I only learned about that very, very recently. If you don't want outputs printing, you can add a semicolon, and so then it doesn't display that output, but it's still stored in the underscore value. If you want to go back more values, you can actually use underscore and then that number. So if I wanted to go back, I want to go back 4 cells. Oops. Maybe not. So if I wanted to go back, it'll go back 11 cells. Or I might not have run 11. If I go back. So if you do 2 underscores, it should go back 2 cells. If you do 3 underscores, it should go back 3 cells. And then if you go back further, then they start to use the underscore and then a number. And that's the same thing as if you do out at a given number. I might not have that many there. So there we go. You can see which values actually produced outputs. So if I did out at cell 9, that was when I computed 12. And we can see that here. So that's within IPython, grabbing values and things like that you computed. Another thing that can be quite handy is you can actually access the underlying operating system. So if I want to run basically bash commands, then I can go in and say, okay, what is my current working directory? So pwd, that's the common bash command. And so I can actually see that this is where I am right now in my operating system, in my file system. You can also actually assign that to variables. So here, if I want to know what files are in my directory, I can actually do, here we're doing the exclamation mark ls. So ls is list the files in there. And so here I can actually assign that, which is kind of cool, and print which files are in this directory. So indeed, these are the files in the directory that we can see here. And then that's the same. So we can run, this is a command that's running and asking what are in the, what's in the variable files. So we're actually passing information back and forth. And you can do different things, like if we actually wanted to format the string files, if we wanted files at 0 to now be all uppercase and to run some sort of command from a command line, you can do that. And that's even available if you actually have multi-line blocks. So the exclamation mark does not have to be the first line or the only line in a function. We can run Python code that actually executes commands on the command line. So if you are used to working with Fortran codes or something like that, and you basically want to set up some input file and then run that code with your input file, you could set up the input file in your notebook, and you could then actually use the exclamation mark to run whatever you normally would from a command line. Okay, so there's something within IPython called Magix. And these are some useful utility tools that are helpful in interactive workflows. And so there's two different versions. There's a line magic, which is a single %, and then there's a cell magic, which is a double %. And so in this case, if we actually ask what does magic do, it tells us a little bit about the magic function. And so we can see there's line magics and cell magics. And so in this case, let's run a time it magic. And so what this is going to do is it's actually going to run this line of code many times and time how long it takes. So this can be helpful if you're benchmarking or trying to improve the speed of your code, trying to understand, how quickly is it running, or if you're trying to diagnose some problem that you're running into if your code is performing slower than expected. And so you can see here that ran in 12 microseconds. Plus or minus 19 nanoseconds per loop. And so it ran, in this case, 10,000 loops. And so that's for a single line of code. We can also run for an entire cell. And so in this case, when you do the double %, that means apply this magic to the entire cell of code. And so in this case, it's going to look, and we're going to run the exact same thing, basically, but now for the entire cell of code. And so line magics work inside of code blocks even, but cell magics always have to be at the top. So if you're going to apply a magic to an entire cell, it always has to be at the top. So magics can basically, there's some really interesting things that you can do. It doesn't actually have to be Python. So in this case, this is actually bash code. And so here we're actually executing a different language in a Python notebook by using the bash magic. That's interesting. See how long that takes. One of the other things that's quite helpful, perhaps with the example that I gave on writing out Fortran codes or interacting with command line codes, is sometimes you actually want to write out a file. So in this case, this write file function is going to write a file called test.txt, and it's going to contain some text in there. And so we can see that it's writing out. And now I have test.txt, and I can actually open that up and take a look at it. And that's the content that we had just written. If you use this, the ls magic is actually going to tell you what kind of magics you have actually installed in your system. So if you want to install magics that interoperate with other languages, like some people like using Julia, you can add Julia. So that you can be running Python in Julia or Python in R, for example, if you have some stats that you want to be doing. Okay, then I want to move on and show a couple other things. So sometimes you're actually running stuff, if you've opened up a Python terminal and you've written some code and now want to bring it into your notebook, you can actually just copy paste exactly what you had run in your terminal, and that will run as valid Python code. Same thing in an IPython terminal. I don't know if you ever run from a command window IPython, it props up an interactive Python terminal, which is sort of the lower level machinery that Jupyter uses. And so you can actually, again, copy paste stuff that you had run in an IPython terminal and have that run in the notebook. So now one thing that I think is quite useful to demonstrate is what happens if we are running code that has errors, and how do you actually interactively debug code. So we're going to write out two functions. So we have a function f, which returns 1 divided by x minus 1, and a function g of y, which returns f of y plus 1. So here, let's do a simple example where we're going to actually just run some code that'll produce an error. So we got a divide by 0 error because, surprise, we tried to divide by 0. But now what I actually want to do is find out, okay, like let's trace back. Let's try and understand what was going on. What was going on? Where did this error come from? So we can run the %debug command. And what that's going to do is prop up a little input that tells us, okay, something went wrong here in this stack. And so if you see this error, it dropped us into the last point here. And it actually has access to all the variables at that point in time. So here, if I ask what x is, so I just typed x and I'm going to run Shift Enter, it's going to tell me that x is 1. And so from there, we can actually see, okay, yeah, our problem is that we're doing 1 minus 1 and then trying to divide by that. You can also go up. So I'm going to type U and hit Enter. And that's going to bring me 1 level up here. So if you look in this stack, this is where we started. And when I went up, it's going to go up 1 level. And I went U. And so now it drops us into the function G. And so here I can ask, well, what was Y? Well, Y was 0. And so that's how we ended up with 1 in that denominator. And the same thing, you can go back down with D. So sometimes if you're trying to do, I often have this when you're trying to do matrix multiplication or something like that, you get back a value that says, hey, the two things don't multiply. And then you realize, okay, the sizes are wrong, but what were the sizes of the things that I input? And so you want to then go in and be able to actually debug and get the sizes of what you were trying to do. One important thing is when you're done with this, right now, so you can see this cell has a star in it, which means it's operating. It's holding your information, holding your kernel active. And so if you then want to be done and keep moving on with your notebook, you need to type quit. If you don't, it's going to keep waiting for input in this debug cell. And so you're sort of like stuck in debug mode. So once you type quit, then you can see that that exits and we can move on. So the same thing, you can actually use that input. So all we were doing is running code in this little input box. And so you can then prompt that if you actually wanted users to be doing something a little more interactive. And so you can go ahead and answer questions and have a little bit more of interactive workflow. Anybody have questions up at this point? I know we're going a little fast, so I just want to take a pause and make sure that people are up to speed. Okay. So I mentioned this with Bash, but we can do the same thing with other languages. So if you wanted to work in Perl, I don't know why, but if you did, you can go ahead and actually run different languages within the same notebook. So I think these next couple things are going to be hopefully highly relevant to the projects and the work that you'll be doing in the coming week. And so I want to take a moment to go through plotting in the notebook, as well as a little bit on widgets. So in this case, there is a matplotlib magic, which lets you put plots right in the notebook. And so often when I'm setting up my notebook, I'll have my imports and matplotlib inline are like always in that first cell of basically every notebook that I've ever written. Has import numpy, import scipy, import matplotlib, and matplotlib inline. So this will let us then go ahead and produce a plot that shows up in the notebook. If you wanted the interactive matplotlib plot, you can use matplotlib notebook. And this then gives you, interesting. I'm not entirely sure. So that might not actually be hooked up. Yes.
So I guess just so what would happen to the plot if you didn't have that plot magic? Since you already have plot. So what would happen?
Okay, so let's actually restart the kernel and try that. So locally, it would pop up a new window with a plot. So if you're running this on your machine.
Okay, so just be inline.
And then here, I think Jupyter Lab is now smart enough that it's actually doing that under the hood for you. But on your local machine, it often will actually create a new window. Yes. You can install other libraries here. So sorry, I'll repeat the question for those of you that didn't hear that. Your name is, sorry? Peter. So Peter was asking if you want to work with multiple languages and you need to install an R package or something like that and actually want to have that up and running with your code. And so in this case, you can access the command line. So if you knew sort of the R command and you had the environment set up to be running R, you can access the command line and do that. With Python packages, you can use, there's a pip Magix, so %pip, and then you can install a package like that. But Don will be showing us afterwards how to actually set up an environment using an environment.yaml file. And so I think that's a bit more tightly tied to your question. Okay, so the next thing I want to show you is some of my favorite pieces of using Jupyter Notebooks, distributing notebooks, and this is working with widgets. And so widgets let you put like small GUI controls on simple functions. And so in this case, what I'm going to do is I've just defined a simple function that is just going to take, so it's called sine of x. It's going to take x, it'll take a frequency, and it'll take a phase shift, and it'll return back sine of that. And so the next thing I do is create a little plotting function that all it's going to do is give me x between 0 and 1. It'll put 200 points in that line, and then it'll plot it. And so here, if I actually go below and I say plot sine x of 1, and let's do a phase shift 0, then I get a sine wave. Okay, so we know how to plot a sine wave. But what gets more exciting, I think, is, okay, let's now actually try and make this interactive. And so this is where the IPyWidgets library comes in. And so there's a simple function called interactive, and what it's going to try and do is look at your function, sine of x, and based on the defaults here, so here I put a default of 1 and a default of 0, both floats, it's going to actually try and pop up sensible widgets for you. So if I run that, oh, do we not have widgets installed? We don't have widgets installed. Oh yeah, no, sorry, we do. Okay, so here, I forgot to display the output. Okay, so in this case, what it did is it gave me 2 slide bars, one for the frequency and one for the phase. And so it used the default values that I have up here, frequency of 1 and phase of 0. And then it gave me some values on either end of that. So in this case, it gave me negative frequencies, which is a bit odd. I mean, you can mathematically compute that, but I don't know if that's exactly what I want to be putting in the hands of students when trying to explain what a sine wave is. And then here, it also gave me phase between 0 and 1. So it gave us sensible defaults, but maybe I want to go in and actually change what those are. So in this case, you can actually specify what you want those widgets to look like. And so here I give interactive my function that I want to interact with. And then I give, in this case, I want a float slider that goes between 0 and maybe 10 and starts at 1. And then for the phase, maybe I want to go between negative pi and pi and have it start at 0. So then in this case, it does that, and we can go in and we can update the frequency and change the phase and have that plot be interactive. One of the things that's kind of handy too is if you were doing some sort of fitting, so sometimes you end up like trying to visually match maybe an exponential or some sort of function to your data. And maybe you set up a little widget to do that and you found that, okay, like this is exactly the fit that I want. What's the value of frequency? And so yes, you can copy it here, but actually the widget stores all of those values. So here, my first widget is frequency. And so if I ask what the value of that is, we get 3.6. So this starts to become pretty powerful, is if you actually want to be doing somewhat interactive analysis and then grab the values that you just found with whatever widget you created. And so I've used this a lot when just trying to plot results, that you end up with a big array of numbers, and then you know that, for example, Z is along your x-axis, you have time along your y-axis, and you want to be plotting slices through that. You can set that up as a widget and then basically sit down and just start, take off your programmer hat and put on your scientist hat and like flip through and look at the different pictures that are coming back at you. So yeah, I think that's an interesting tool. And you can see like other widgets. So if I didn't want that to be a float slider, maybe I wanted it to be a float text. You can enter a text box. And so here, now it is a text entry box. And so the IPyWidgets documentation has a big page that shows you all of the different types of widgets that you can work with. Are there questions on this? No? Okay. Do we want to go through the slides, or do you want to jump up and talk about it? I feel like yeah, okay. So there's a set of slides. There's a link if you actually go to the repository. There's a set of slides here, Intro to Jupyter and Binder. If you want to follow along, you're welcome to. And I'll walk through these fairly briefly because I want to make sure that we have enough time to go over environments and Conda. But I think it's helpful to get just a bit of a big picture sense of what Jupyter is and what it means to be working on the cloud, and go from there. Okay, so one of the questions we get asked quite often is like, what is Jupyter? And so some people say, you know, Jupyter is the Jupyter Notebook. And so that's one piece of it. But now what you've seen and what we've interacted with is Jupyter Hub. And so that's much more than the notebook. That's how you actually deploy Jupyter for multiple users on the cloud or on a big server, something like that. IPyWidgets is part of the Jupyter ecosystem. And so I guess the best definition that I've seen so far is that Jupyter is a community of people and an ecosystem of open tools and standards for interactive computing.
I want to stress to people the kind of connection that we're talking about this week. You know, this morning we talked a little bit about reproducible code, which is the way we can share our work. And I think what it's really saying, and just some really important aspect here, is that we're now in some ways have reproducible computation or platform packaging. The way in which we could have, for example, a lab, not have to spin up individual instances, but have a fixed instance that you didn't have to worry about all those requirements. And so it's the broader narrative here of how do we make things reproducible and easy to share. So I know labs which have Jupyter hubs that hold their essential data sets, their essential packages, and that allows them to share computation in a way that it's pretty easy to get up and work. You have a Git repo where your code might be stored, and then a hub setup, which might hold your packages and your computation. And so I was just trying to sort of piece that together.
That actually leads very nicely into my next slide. And so some of you may have seen this quote. This is a paraphrasing of John Claerbout, who is a geophysicist. And so what he said, and I'll read this quote, is an article about computational science in a scientific publication is not the scholarship itself. It is merely advertising of the scholarship. The actual scholarship is the complete software development environment and the complete set of instructions which generated the figures. And so I think that Jupyter, and what we're trying to get at, and what Ben was just saying, is really how do we actually capture the complete development environment? And so we'll go into that briefly here. Don will introduce that. And the complete set of instructions, which in this case could be your notebook. There's one other piece that I would like to add, and in this case, we have the Pangeo. There's also a tool called Binder, and that actually gives you a place to run the code. And so I think it's important to take a step back and ask, why do we care about reproducibility? Beyond scientific integrity, I mean, that is clearly an important piece. But I think the thing that we're seeing as we're actually entering into much more collaborative workflows is that in order to actually pass off and engage and work with other people, you have to be able to reproduce their work. You have to be able to start from the same place. And so being able to work together on a project means that you actually have to have good practices about reproducibility built in from the base. Also to build on the work of others and have others build upon your work is if you've done something useful and you want people to be able to make use of it, you want them to be able to pick it up and get running. So I'll give a quick tie-in with each of these 3 points that we found in that quote. So how do we capture the complete set of instructions, the complete development environment, and how do we set up a place to run the code? So let's start with the instructions. So we've worked a bit with Python, but R and Julia are also growing and have open communities around them. And so open source languages are really the starting point. Is, you know, we're starting with something that anyone in the world can access, and anyone can pick up that set of instructions that you've written. And around those, there's maturing ecosystems of tools. And so you don't actually, there's very few cases where you're going to be writing a script that is actually in pure low-level Python. You'll be importing libraries and being able to build upon the work of others who've set up things like NumPy and plotting and Xarray and Mask. And so you don't actually have to have gone in and figured out how to set up a parallel computing deployment on a Jupyter Hub. You can just import that and get running. One of the things that I think is important in understanding what Jupyter is, when we talk about standards, it actually means that, you know, Jupyter set up a message passing system and a specification for that system so that you can plug in any other front end you want. So for example, Interact is a front end that's used a lot in education, and it's championed by some of the folks at Netflix. And it's a completely different front end to Jupyter, but it still uses the Jupyter message passing system. And so it can plug in and interoperate with all of the other Jupyter architecture. So as we saw, a Jupyter Notebook provides a way to capture the complete set of instructions. So it runs in a web browser, which means that you can actually run the same thing. It looks the same to you as if you're running on your local machine and running on the cloud. That there's no real visual huge differences, which is quite nice. We showed that you can add text, comments, equations, and have that be combined with code and interactive widgets and visualizations. So when you're actually looking at a notebook, there's a few different things that you need to think of as to actually, how does that actually become a live interactive document? And so we see the Jupyter Notebook document, which is actually just stored as a big JSON file. So that's a bunch of text that's stored. But in order to actually have that be something consumable, we need an interface like Jupyter or Interact or RStudio. And then we need the software development, the software environment. So when you run the line, import NumPy as NP, that NumPy is actually in that software environment. We've talked a little bit about Git and GitHub and how to actually track your changes and have those be stored and versioned. There's a lot of other tools, and I'm happy to chat, and I'm sure many of the other instructors, if you're interested in going a bit deeper and seeing things about like documentation or testing, we'll touch on testing a little bit later in the week, but happy to chat about any of those things for folks who want to go deeper. Okay, so now this is getting just a little bit into how do you actually structure a repository so that it is something that can be shared. And so we showed a repository that has a Readme, which is a set of instructions, has a license, so that people know how they're allowed to use your code. One thing that a lot of people don't realize is that if you don't have a license, it actually means nobody else is allowed to use your code. So it's actually copywritten to you if you don't have a license in there. So that prohibits others from picking up and using your work. So specifying the terms under which they can use it is important. And then perhaps a notebook. So then we talk about capturing the complete development environment, and I'll give you a quick overview, and then Don will go into some more details on this. And one of the tools that is an interesting one within the Jupyter ecosystem, and this is how mybinder.org runs. How many of you have seen mybinder.org? No? So I'll show you a quick, when you actually, there's a lot of repositories that when you look at, they've got this launch binder button. And so what that actually does is it takes this repository and it will build you a software environment on, right now there's 2 different places where mybinder.org has computational resources donated. So Google Compute Engine and OVH, which is a cloud in Europe. So they have provided compute resources for the MyBinder project. And when you click on this link, it's actually going to set up, it's going to look at this repository. and build an environment based on the specifications that we've put in there, and drop you into a live interactive computing environment. Yes, exactly. So in this case, there are standard practices. And so for Python, using an environment.yaml file is standard practice for specifying what is the software that you need to be able to run this notebook. And so if we looked at the Geohackweek data sharing repository, you'll see that there is an environment.yaml file, and that's what Repo to Docker is going to look at to build you a computational environment. So when it says Repo to Docker, it's basically it looks at this environment.yaml file, and we'll build you a container that has all of that software in it. And that's what Docker effectively is. And so John will show some more of this. I was showing this actually at a stats conference, so wanted to show people what R looks like as well. Because they also have a standard practice around how to specify packages. But this is the style that we'll be using. You set up a file that has a name, tells you what channels you're going to be getting software from, and then lists those dependencies in there. And then what Binder is doing right now is it basically is running Repo to Docker, which takes this file and builds you a software container that actually has all of that software installed, so that when you click on the notebook and get it up and running, you have everything that you need at your fingertips. And so that's basically what a full repository needs, is you need the notebooks, you need some information about what's in your repository, like in a Readme. You need a license, which tells people how they can use it. And then you need specifications on what that environment looks like. So this one was in R, but in Python, you would be using an environment.yaml. And so that's what my binder is doing, is it actually combines all of these pieces and gives you that last piece of an environment that's up and running in the cloud. And so we'll see if that, no, it's still thinking, that's okay. So what you can think of Binder is basically Repo to Docker, which I told you builds that container, plus Jupyter Hub. And so Jupyter Hub is infrastructure for building Jupyter environments for multiple users. So when you downloaded Anaconda, for example, and run stuff locally on your machine, that's a single user Jupyter installation. But when we're accessing something like Pangeo, it now needs to be able to run for multiple users. And so Jupyter Hub provides everything that an administrator needs to basically specify each person should have this much CPU and this much RAM, and sets all that out for you. In these slides, there's a couple cool examples. I won't go into them now, but if you're interested in seeing some of the cool examples that have been run recently, there's actually a binder that's been created for the discovery of gravitational waves. So you can actually go in and play with their data. And so it's a really nice example. So you can check that out. If you do, at the end of the week or at any point in time during the week, if you want to get your repository up and running on Binder, I'm happy to help hold perhaps another session or a quick breakout group on how to actually do that. But when you land on the webpage, it'll look something like this. You just put your URL here, and as long as you've defined an environment file and you have some notebooks in there, it has everything that it needs to build a computational environment so that you can send anyone in the world this link and they can run your code.
Can you specify your environment? Because let's say I have some AWS. Can I say, here are my credentials? Can I binder to my own resources?
Not right now, no. There's tools for setting up your own binder. So if you wanted to, like if you had some resources and want to set up a binder on AWS for your group and have it be authenticated, you can do that. But there isn't sort of a global cloud system for being able to drop Jupyter.
Give us like the philosophy of science thing, like we want this thing to last. And so if I put this in a paper, Google Cloud can leave us tomorrow and say, hey, this was great, but we're done with this. Whereas it was my lab could at least make a statement of like, we're going to hold on to this thing for 50 years. So it would be interesting to, from a reproducible standpoint, this is still incredible, but we still need to back it with something.
Well, I think there's a question of, sorry, for those who didn't hear the comments, I'll try and summarize that briefly, but Ben was saying that, you know, there's no guarantee that Google is always going to support MyBinder, and so, you know, if we actually want to have reproducible computations, should we be running our own? And could we be setting up our own? And so there are tools. I mean, all of the stack to create mybinder.org is open source. And so if you wanted to spin up your own version of this, you can. The other thing is that by specifying the environment and the notebooks and having perhaps some testing in place, although it's not necessarily the same thing as a live computation, that you have captured all of the pieces that are necessary to run the code. And so you should be able to drop that anywhere. All right. So with that, just pointing out that this is and this photo even is a subset of the team of people who have contributed to making Binder and Jupyter Hub possible. That's this photo more specifically. And so, yeah, I mean, it's an enormous effort. There's lots of places where people can jump in. And so if you're interested in contributing or getting a little bit more involved in Jupyter development, feel free to wave me down. I'm happy to chat and show and yeah, get some more geoscientists on board. Are there any other questions that people have about Jupyter, Binder? I know that was a bit of a whirlwind tour, but hopefully useful. Yes. Sure. So the question was, how do you actually shut down your notebooks and save your workspace? So let's go back to the Jupyter lab here. Oh, it was this one. Sorry, I had multiple tabs. So in this case, one of the things that you can see, there are green dots running here. That's showing us that those kernels are live. And so that means there's a computation, like you can jump into this notebook and there's active computational resources at your fingertips. And so let's say I'm done working on the Beyond Plain Python. What I can do is right click and I can shut down the kernel. So I can stop the kernel. So now you can see up here it says no kernel and the green dot has gone. So that means that notebook has been stopped and we're done with it. And so we can close that off. For saving, it's the same thing as if you are saving like a Word document. You can do Control S or Command S or File Save, I believe. Yeah, Save Notebook or Save Notebook As if you wanted to make a copy. And then when you're all done with your session, you can actually go to the Hub Control panel or you can log out directly. So if I go to the Hub Control panel, I can stop my server. And that will actually shut down my environment and shut down my session. And then we can exit out from there. So, and then the other option is to start and log out. All right.
Great. Well, let's thank Lindsey for a great tutorial.
Okay, so Lindsey, I've talked a lot about Conda, not a lot about Conda, a lot about environments. And today I'm going to talk to you guys about Conda. So Conda is a package and Python, well, it's not just Python, package and environment manager for software packages. So I will get started by looking at this picture of a perfect Python environment. Basically, everything's all nice, and this Python is very happy with the environment. Nothing's breaking, and you know, it gets its water and everything. So awesome. Okay, so what is the definition of a Python virtual environment? So just get a set of hands. How many people are familiar with creating Python environments or really any package environments? Okay, that's a good chunk. Cool. So I will start with a little discussion in case everybody has access to this under Pangeo. So that should be, so this notebook is under data sharing notebooks and the Conda. And under there's a URL here. So we're just gonna brainstorm about what are the benefits of having a well-defined Python environment. So this is more like a review of kind of what Lindsey have talked about earlier. If you guys can just, type in there what you think are the benefits of having a great Python environment. All right, some people are starting to fill in. I'll give it like a few seconds. Code reproducibility, package conflicts, transfer between multiple computers. Awesome. I like the +1 there for package conflicts. Avoid dependency hell. All right. Oh, still. Python versions, very important, and allow external collaborators to run scripts. Cool. That's actually really efficient, all the +1s, +2s, +3s. Awesome. All right, well, this, this is an ongoing discussion, and feel free to fill in whatever else that you guys have. But basically, what you have listed are exactly what I'm going to go over today. So basically, in summary, avoid future breakage on any dependencies changes when you have a Python environment, and also allows better collaborations among team, and of course reliability on your any software or research that you are doing with a well-defined Python environment. So there are in this tutorial I'm going to cover just Python, but Conda is actually, like I said earlier, is a universal universal package and environment manager. So for Python, the most classic one for a Python package manager is pip, and also along with that is virtual env to manage its environment. And right now, the modern way of managing Python package and environments are pipenv. So, but what we'll learn is Conda, which is even a better step on managing Python packages and environment. So just a little review of preliminary. Like I said, Conda, open source package environment management system. This works for really any software languages. You have Python, R, Ruby, Scala, Java, JavaScript, C++, Fortran. And it can manage all those very low-level dependencies and so on. And there are two flavors of Conda. There's Mini Conda and Anaconda. So Anaconda is a data science platform where when you install Anaconda, it will install all these other scientific packages along with it. But if you want to just build your own environment that is from scratch, where there's a lightweight distribution of Conda called Mini Conda. So I'm just going to show you a scenario of these two students. One is Bob. Let me see, how do I decrease the size? Command plus. I want to decrease. There you go. Got it. Cool. All right. So it's gonna play this. So Bob is going to create a Python environment with pipenv, and he's going to install packages like gdoll. And it's just going really fast because I'm running out of time here. But as you can see here, so he created that. He's trying to install gdoll just using pipenv. Pipenv install gdoll, and look at all the traceback that he's getting. Like, why is this happening? I have no idea. So Bob looked up, this gdoll help, but still confused and don't know what's going on, right? And how many of you have encountered that? Trying to, all right, most of you. Exactly, it's really frustrating. I know the first time I tried to install gdoll was this way, and that was a mess. I spent like pretty much a week trying to figure it out what's going on. So yeah, so now we will see scenario 2, Sandy, who has been at Hack Week before and know of Conda, will try to install gdoll. So Sandy is going to install All right, Sandy, let's go. Okay, so she's just activating Conda and then checking she has the right Conda version, creating a new repository, and then going into the repository and creating an environment.yaml file, which Lindsey mentioned earlier, with Conda and any other, geospatial, Fiona, and so on. Just making sure that she did it right. And then now she's creating that whole environment that has Conda, Fiona, GDAL, and NetCFR into the Conda environment. And then, so Conda will resolve any dependency. So it'll figure out, okay, what version of GDAL am I installing and what does that need? And then, so it'll install all these. So GDAL, have these very low level packages that needs to be installed. And the problem that you encountered when trying to install GDAL by just pip installing is because the maintainer of the package did not include those C dependencies in their wheel. So all those binary dependencies are not included in there, where in Conda, they are included. So when you install GDAL, it's less headache there. Everything's all included. And so you just, like you see here, she just basically, oh, I'm done. All right, there's GDAL, OGR to OGR, I'm ready to go. Yeah. So what's going on? Well, pipenv is basically just a nice wrapper to use pip and visual env together under the hood. So pip is simply just a Python package manager. So it only installs and install Python packages and not really the lower level dependencies. And there are pip wheels, which the package creator has to maintain. So wheels can be installed, and those pip wheels are kind of like I said, the lower level dependencies that's needed. But some, it takes a lot of work to manage a package, especially those that require like Fortran or C and all sorts of things, and not just pure Python. So, some of the people just don't want to do the work. It's just too much work. So, so there are only some packages that might work pip install, and then everything's all good if they include the lower level, but not very many. So, and then pip also does not handle library dependencies outside of Python packages. So like if there is an update in GDAL, and then it might pip if you try to install, or like just any other Python package you try to install, and then the other package dependencies are, it doesn't try to solve the matter of this package might need that other package, but it's not updated yet, so it's not able to install that. Yeah, but then now comes Conda, which can solve all those problems and manage. So here's just a nice quick, let's see now, how do I zoom again? Can you guys see that? Kind of. Let's see. Okay. All right, so this is in short, Conda environments. This is what it looks like. So when you install Conda, you automatically get this root environment. And I warn you, this is a big, like a best practice here. Do not install anything else in your root Conda environment. You don't want to destroy that at all. You want to keep that environment clean, and Conda root environment, you want to keep it clean, and you just, it's easy to create new environments on top and just keep the root one, just default. And so what Conda does here is basically, okay, Conda install, my geo environment. And so it'll just go look at whatever other environment that you have and then grab those packages and then switch back and forth. You can have a zillion environments in Conda. And the nice thing about Conda is it will actually look at what packages that you have installed, so you don't have multiple, files in your system, so it won't get super bulky, because every time you install your environment, if a version already exists in other environments, it's gonna just basically do a symlink onto that. So it's, you know, it doesn't fill up your system if you already have those things. So here's some command. I'm not gonna go through this because we're running out of time here. But here's, so in your spare time later, just try out creating environments with these commands. And then here's a sample of the environment.yaml. Lindsey I've showed earlier, where you put the name of the environment that you want to create, and then the channel. And I will talk about channels in a second. And then dependencies. So dependencies is the list of the environment, the packages that you want to install. And then the channel is where you want to get those packages from. So here's just a best practice of to share environments. You know, I usually suggest that when you start a project, create a new environment file, and then, you know, list out anything that you need from there. And then as you add more packages to the environment, and, you know, as your project build up, and then you need, say you need NumPy later, or you need Rasterio later, then update the environment file, and then update your Conda environment from that file. And then unless you have a production environment where, you know, you don't want dependencies or version changing, you know, I suggest just keep it, you know, keep it clean like this with no hard-coded version in there, so that you always, you know, try things out up to date with the new changes in the library. Okay, so channels are like storages. So here's just what a channel looks like. So channel is that lives up in provided by Anaconda Cloud, where a bunch of packages live, and this is where you install. It's like an app store in a way that, you know, you want to install a package from these trusted channel, then you just install it from there, and Conda will grab the package, download from that channel. So, and then here's just some commands to list out your channels. And I would like to highlight, well, here's just an important note here that the highest priority channel is where your package will be installed from first, no matter if another channel has a higher version. So in here, in your Conda environment, this channels listing, if Conda Forge is the very top one, it will install for Conda Forge first, and then whatever other else channel that you want. But I suggest that you only stick with one channel. And this channel here, Conda Forge, is a very trusted channel. It is a community-led collection of recipes, build infrastructure and distribution for the Conda Package Manager. It is a community channel, so any one of you can create a package and submit your package in Conda Forge for other people to install. Yeah, and here's some resource about how to do that. And then just the Conda packages are basically like a Python package. It's a compiled software package. When installed, also includes all of the dependencies, even the lower ones. It is cross-platform when, you know, and it's built from what's called a Conda recipe, which I will show here. So this is an example of a Conda recipe. So this is just a pandas recipe. So this here points to where the source code is. And then usually if you have any other dependencies like R or Fortran or C or whatever, it will be, you know, it'll be described in here. And yeah, I know I went really fast on that because we're running out of time, but if you have any questions about Conda or, you know, anything, any help with that, let me know. And just one note one note on why I'm showing you this is because, so the Conda environment can act as basically the kernel within your Jupyter notebook. So when you install a Conda environment, and you want to use that set of environment in your Jupyter Notebook, you can do that. And I'm just going to show you real quick the data sharing environment file that we have. So like this one, you can install this, and one of the key packages that allows you to create this environment and make it a kernel is these two packages, NB Conda kernels and IPyKernel. And if you install those, you know, then you can use those set of packages within your IPython notebook kernel environment. So yeah, and I will turn to Joe with the next thing. Yeah.
All right. So for the last piece here, which I would like to send you off before we get into our project building, is a little sample repository we put together on the Geohackweek website, or more to speak, the GitHub site. So, and this is only a reference, should be by no means be the standard you're going to be held against and late on Friday when you present your projects. This is just something we put together over the last years to what we thought was a good way of organizing you as a project in order to reduce the merge conflicts. If you've never heard of a merge conflict, you will face one this week. I will guarantee you that too. But anywho, so let's walk through this repository real quick and see what's in there. So first of all, as we talked about it, there's our environment.yaml. So these are the packages we're going to use, or you're going to use in your projects, and list them all out. I would recommend that you start that document early. So there's one way of doing it after the fact, which will create you more problems, and you just take Honda to create it for you. I will say, just start off, if you have a package, put the name in there and commit it. This will save you a lot of headaches recreating it after the fact. So this is the first thing. Then as always, we're going to put a README in there. And the README, I have a little sample link in here. This is something that leads you to the wiki site. So what we're going to put in here is some elements of a good README that when someone else comes to your repository, he will know, or she, what is going on, what's the problem that's going to be solved, who are the contributors. And this is all kind of held in this sample document out here. Another thing that we haven't touched yet on Git, there are certain files that Git is not very happy of version controlling, and they will be ignored with something called the .gitignore. So every good sample repository has those files in there, and I put in here is a standard file template that exists on GitHub. So whenever you start a new repository, they ask you, do you want to also create a standard gitignore? And this is the one you see right in here. So this will basically tell Git that these kind of files should not be in my Git repository because they are not part of this project, that they are created, for instance, if you run tests or you have some big binary files or something that is not very well kept up in version control. This will tell Git, don't worry about it. We'll just commit other files that you're good of and version controlling. So every good sample repository has those files. So when someone else forks this and then commits that work he does for your project, he not accidentally commits files in there that shouldn't be a part of the repository. Another thing would be, for instance, sample data. I highly recommend not put sample data into a repository that is very big, because your repository will explode in size and no one is happily downloading gigs of data just to look at some code locally. So keep that in mind. Gitignore is a good file to keep track of things you should not have in version control. The other two things are here that are contributors. So each of you will, put his effort into the project, but he wants to play around, right? You want to mess stuff up, you want to delete things, but you don't want to affect other people's work. So the way that other people have organized it in the past years, that they create under their repository the contributors folder, and everybody gets a little playground, so to speak, here, where you can just break the chain. I mean, do whatever you want in there. And whenever you're ready, then just say, okay, this is my notebook, this is my piece of contribution to this package, this is the place where it lives. You commit it, and then you get to merge that without any conflicts into the main repository. Notebooks is the folder that people have used in the past, which were their presentation work on Friday. So once had all the individual team members, they had their notebooks where they put together the individual contributions. And by the end of the week, we're going to do a presentation. And the easiest way is to have one big notebook there, or maybe several chapters, because you did some data crunching, some data analysis, some nice plotting. So these will be kind of your final production elements you have at the end of this week. And this will be then the folder you can also point to in your README saying, all this great work we did, look at the notebooks folder, and this is our results. Scripts, it's kind of a small one, but if you have any other scripts that are not notebook related, but they help you convert data or anything like that, these are kind of command line executable things, kind of can keep them separate from the notebooks. So if people want to use them, they kind of easily navigate into that. And this is pretty much basically it. So this is the sample that has been evolving over the last years that has worked well. If you have a good idea, well, in our peer learning system, I'm happy if I see some pull requests to this. So maybe you have a new structure, you have a new idea, or you have some other elements you think, hey, these are useful, this should be in there. Send us a pull request. I mean, this also will live and will go on. You will learn new things that they haven't had in Hack Weeks before. So we can then pass it on so other people that come next year or the years after have a new sample repository that will all kind of evolve over the years. So feel free to fork this, clone this, do whatever with it, and send me pull requests. I will hopefully get a few by the end of the week. A license? Sure. Should we do that license now, or should we do it Friday with the brief mention? Yeah, here we are, settings. So Lindsey just mentioned, as always, if we don't put a license in here, that this is our work that no one is allowed to use. So it's always good to do that. And now, Lindsey, I guess you should help me. Insights. Okay, here it is. So I guess for every general navigation, I'm learning something new today. Here, Insights was the tab I navigated first to, then Community. And here's your checklist also for your repository, what you should add. And I guess I was naughty. I didn't put a license in here. And here you can choose a license. And GitHub can walk you through which kind, and which one should we use, Lindsey?
So if you go back and to the add, and then you can choose which one you.
BSD2, 3.
BSD3.
3. All right. Right. Okay. We agreed upon. BSD3 license, and here it is. License. Let's see if code gets credit for it. So, and the other thing I have in here too is this repository list by pull requests. And this is also another good thing you can do, you as a team collaborator, and practice it throughout the week. Clone this repository down, create your branch, contribute, and put up a pull request against the main repository, against the master branch. I recommend that. I have some handouts if you want to see a Git flow for teams. Come by and I can give you a little cheat sheet, and we can also walk through if you want to. But really use this week to use the branching concept, do your work, and come back. Question?
You can install finite environments as individual users, but every time that you stop your server, it will all disappear. So it's good if you, I mean, I think Scott has a little hack so that it stays there, but yeah, I don't know. That's all on Scott.
Sure. Yeah, there is a workaround for that currently. So if people are interested in doing that as part of your projects, then we can do a short demonstration of how to close that maybe tomorrow.
But I suggest just keep an environment YAML file in your repository and just keep recreating, I guess.
Okay, well, let's thank Joe and Don for those tutorials.